Calculating masses of reactants and products. So this is our stoichiometry. First, you need to make sure you have a balanced equation. You need to convert to moles and set up your mole ratio to convert from one substance to another substance, and then convert those moles to the desired unit wanted in the problem. No matter how you solve these problems, you must clearly write the units and compounds next to each of your numbers to earn full points on each question. Make sure to show all your work, whether you use the technique that I have or you use another technique that you've learned from your previous teachers. You just need to make sure that you show your work. Alright, so calculate the mass of nitrogen produced from 10.8 grams of ammonium dichromate in an ammonium dichromate volcanic reaction. Alright, so I have 10 grams of ammonium dichromate, and I want to know the mass of nitrogen, and nitrogen, or mass is measured in grams. So I'm going to take 10 grams and the first thing I want to do is convert that to moles. So adding up the molar mass of ammonium dichromate, I get 264 grams. Then I'm going to use the molar mass. So up here is my equation balanced. No, it's not. I have 2 nitrogens, 2 chromates, 2 chromates, 7 oxygens, 3 and 1 is 4, so my oxygens are not balanced. And then I have 8 hydrogens and only 2 hydrogens, so my hydrogens aren't balanced. If I put a 4 here to balance my hydrogen, 3 and 4 oxygens make 7, so now it is balanced. So it is a 1-to-1 mole ratio. And then I want grams of nitrogen, so I'm going to use the molar mass. 1 mole is 28 grams of nitrogen. And then we're going to multiply, divide, multiply, divide, multiply, divide, and we get an answer of 1.15 grams of N2. So my grams cancel because I'm dividing. My moles cancel because I'm dividing. My moles of nitrogen cancel because I'm dividing. And then I'm left with my unit of grams of sodium. Here's another problem. Coke is an impure form of carbon that is often used in industry production of metals from their oxides. If a sample of coke is 95% carbon by mass, determine the mass of coke needed to react completely with 1 ton of copper 2 oxide. So we have a lot of stuff happening here. First thing that I'm going to recognize is that I was given an amount of 1 ton of carbon 2 oxide. The other thing that I'm going to note is that I'm looking for coke, which is not in my reaction because it's an impure form of carbon. Carbon is in my reaction, so that's what I'm going to solve for, and then I'm going to convert it to coke. So I want to know grams of carbon, and then I know for based on the mass percent that there's 95 grams of carbon for every 100 grams of coke. So I have 1 ton of copper 2 oxide. I want to convert that to moles. In order to do that, I need to convert it to grams. So 1 ton of copper 2 oxide is 2,000 pounds. And 1 pound is 450 grams. And then the molar mass is 79.5 grams for every 1 mole. This reaction is already balanced because we have the coefficients already in place. So I know the mole ratio is 2 moles to 1 of carbon, and then 1 mole of carbon is 12 grams of carbon, and there's 95 grams of carbon in 100 grams of Coke. Alright, so we're going to multiply and divide here. The ton would cancel, pounds would cancel, grams would cancel, moles would cancel, moles of carbon would cancel, grams of carbon would cancel, leaving us with grams of Coke. So if we multiply and divide across, we get an answer of 7 times 10 to the 4th grams. Notice that I have numbers, units, and substance every single time we write it. Limiting reactant is a reactant that is consumed first and limits the amount of products formed. You'll know you'll have this type of problem when you're given amounts for more than one reactant. Alright, in the real world, we don't sit there with one reactant and that's it. We usually have more than one reactant and we're mixing those amounts together. So we need to know which amount is going to limit how much we can form of our product. So that's a limiting reactant. So if you're given information about more than one reactant, then it's a limiting reactant problem. And just remember that your reactants are found at the rear of the arrow, which is on the left. Alright, so some terms here. Chemicals are often mixed in stoichiometric quantities, and that just means that it's a perfect mix, so all the reactants run out at the same time. Stoichiometric quantities. All reactants go to 0 at the same time. A limiting reactant limits the reaction. The excess reactant is leftover reactant, so it's not all consumed. And then reagent is just another term for reactant. So if you ever see limiting reagent, excess reagent, it's the same thing as a reactant. To solve stoichiometric problems, you want to balance the equation. You're going to take the mass or amounts of your reactants and convert them into moles. Then you're going to determine which one is the limiting reactant using the coefficients from the balanced reaction. You're going to use the moles of the limiting reactant to figure out the answer to the problem. You always want to use the limiting reactant to determine the final answer. Convert from moles of whatever it is that you're looking for to the units that you're looking for. Okay, so our problem here. Methanol, which we know is CH3OH, is the simplest form of the alcohols. It's synthesized by the reaction of hydrogen and carbon monoxide. If 1.4 times 10 to the 4th grams of carbon monoxide reacts with 1.5 times 10 to the 3rd grams of hydrogen, which is a limiting reactant? So here I have information about more than one reactant. I know information about carbon monoxide and hydrogen. So the first thing I want to do is convert those to moles. Notice that it's 2 grams of H2 because you have 2 hydrogens. Okay, then we need to go to the balanced equation. So this reaction is already balanced because it has the coefficient there. And what it's saying is for every 1 mole of CO, I need 2 moles of H2. So if I have 500 moles of carbon monoxide, I need twice that amount of hydrogen. Well, I don't have twice that amount of hydrogen. So that means hydrogen is my limiting reactant and carbon monoxide is my excess reactant. Alright, so again, My balanced equation tells me I need a 1:2 ratio. I have 500 moles of carbon monoxide, so I should have 1,000 moles of hydrogen. But I don't. I have less than that, so hydrogen is my limiting reactant. All right, number 2. How many moles of the excess reactant remain unchanged? Out of my 500 moles of carbon monoxide, how much is going to be left after the reaction takes place? So if I'm going to use 750 moles of hydrogen, how many moles of carbon monoxide am I actually going to use? Alright, so I'm actually going to use only 375 moles of carbon monoxide. So I'm going to take my 500 moles that I started with, subtract my 375 moles that I've used, and that tells me I have 125 moles of carbon monoxide not used, left over, unchanged. Alright, so at the bottom here, how many moles of methanol are formed? Again, you have to start with your limiting reactant. And then you can set up your mole ratio. If it asks me for grams, I could continue and find grams of methanol. Alright, so our answer is 375 moles of methanol. And let me just clarify something here. We had 375 moles of CO used and 375 moles of methanol produced. Are they always going to be the same answers here? No, it just happens to be the same answers because our mole ratios happen to be the same. So it's all based on the mole ratios in that balanced reaction.